In this video, we're going to talk about polynomial functions. So I want to start by giving you a definition of a polynomial, and then we're going to talk in this video about adding, subtracting, and multiplying polynomials together and try to give you some examples of that. To start off, we need some vocabulary. So a term is defined to be something where we have numbers and variables multiplied. So some examples might be 2x or 5x squared or 3y to the fifth. Okay, so numbers and variables kind of multiplied together. A polynomial then is a term, a single term, or a finite sum of terms. Let's stop there for a second. A sum of terms just means we're going to take a bunch of terms like this and add them together. Finite here means that at some point I have to stop adding. So I can't have like x plus 2x plus 3x plus 4x plus dot dot dot. Right? No dot dot dots, even if there is a nice pattern. That would be an infinite sum. Right? We would keep adding forever. And to be a polynomial, it needs to be finite, which means it comes to an end. Okay, and then to go on, it says with only 0 or positive integer exponents on the variables. All right, so let's test this out. I have a few examples here. Let's try to decide, are they polynomials or not? So how about choice A? Is this a polynomial? Yes, absolutely it is, right? These are 4 terms added or subtracted together. We have nice exponents, right? So this is a yes. What about B? This is a no, because we need to have integer exponents, which means a whole number, right? So no fractions, no decimals. This is causing the problem, right? I can't have an exponent of 1/2. So I'll just put that here. So x to the 1/2, we can't have that. We also cannot have, that would be the same as the square root of x. So no square roots, cube roots, or anything like that, right? Those are not part of a polynomial. Okay, what about C? C is also a no. Can you spot the problem? The exponents on the variables have to be positive, or they could be 0, right? But they cannot be negative. And so that's a problem here. So the 6x to the -1 is a problem. This would be the same as 6 over x. So we also cannot have fractions with variables in the bottom of the fraction. We can have fractions of numbers with variables either in the top or out to the side, but we can't have variables in the bottom. That is not considered a polynomial. Okay, what about the last one, 6? This is always a tricky one, right? 6 is actually okay. It's a yes. We said it could be a single term, right? And so 6 is one term. If it bothers you that there's no variable, you could think of this as 6x to the 0. Anything raised to the 0 power is 1, so this doesn't really change anything. So it's a yes. Okay, there's a little bit more vocabulary here that I thought would be important to mention. Descending order is usually how we write our polynomials. Here's an example that is already in descending order. This is where we have the exponents kind of in order from largest to smallest, counting down. So this means, right, we have the exponents arranged largest to smallest. Okay, the degree of a polynomial is going to be important in our class and in college algebra. For a polynomial that just has one variable like this one, the degree is the highest exponent. Okay, so what would be the degree here? Definitely the 3, right? And so when we talk about degree, it kind of describes the power of this polynomial, so that as I plug in for x a bigger and bigger number, it describes how fast is it going to grow. The leading coefficient also is important to recognize, and that's the number in front of the highest exponent. So if the polynomial is written in descending order, where the exponents are arranged from biggest, largest to smallest, the leading coefficient is always going to be in the front, right? So this time that's the -2. Both the degree and the leading coefficient have an effect on the shape of the graph. So even though we're not going to be graphing polynomials in this class, in a later class you will be doing that, and so you will need to make sure you can identify the degree and the leading coefficient. Okay, now we're going to look at adding, subtracting, and multiplying polynomials. So we'll start with adding and subtracting. The basic idea for adding and subtracting is just that we're going to combine like terms. And like terms mean that we can combine anything that has both the same variables raised to the same exponents, right? And so in these examples, I'm just using one variable, but if we had multiple variables, all the exponents on those variables would have to match in order for them to be considered alike. Okay, so your book actually goes through several different ways for adding and subtracting polynomials. You can do it horizontally, which is how I like to do it, or you could kind of line these up and line up the matching powers and add them vertically, kind of like you would when you're adding two really big numbers where you line up the digits, the place values. Okay, so I'm going to let you look in the book if you want to see the vertical method. It's all there spelled out very nicely, but I'm just going to look at horizontal method for now. So when I do the horizontal method, I want to look for like terms, I want to combine them, and I want to write my answer in that descending order. So I want to do the highest powers first and sort of count down to the lowest. So it looks like the highest exponent I have in both of these polynomials is y to the 4th. And I have two of those, right? So I have 2y to the 4th and I have 4y to the 4th. So I want to combine those to make 6y to the 4th. For y cubed, I just have the 1, 7y cubed. For y squared, I've got negative 3y squared and positive 6y squared. So I want to add those up to make a positive 3y squared. And then exponent of 1 would be the y to the 1st. That's the only thing left. Okay, so this is how we can add polynomials together. Let's do one more example, that's subtraction. So if I'm subtracting, I do have one extra step, and that is to distribute this negative to everything in the second polynomial. Right? Because subtracting is a lot like adding the opposite, and so we're making the opposite. Okay, so I'm going to go ahead and write that out. I think that's important. I'm going to take off the parentheses, and when I take the parentheses off, that's when I distribute the negative. So I'll have negative 3x to the 4th plus 2x cubed minus 3x plus 4. Now this really is just like the problem we just did. We're just combining like terms, and we want to write the final answer in descending order. So I'm going to start with the highest exponent again, which is the x to the fourth. So I have 4x to the fourth and negative 3x to the fourth. So that's just going to give me 1x to the fourth. Then I have negative 2x cubed and positive 2x cubed. So those are actually going to add to 0 and cancel each other out. Then I just have one x squared term, 5x squared. For x to the first, I have minus x and minus 3x. So together, that's negative 4x. And then I have positive 8 and positive 4. So that'll give me positive 12. All right, so hopefully that gives you a good idea of how to add and subtract. We're really just combining like terms. But if we subtract, we do need to remember this distribute the negative. That's really important and really easy to forget. All right, now let's take a look at multiplying. This is actually in the next section of the book if you're keeping track of that. And I put in here some of the terminology, right? So if I have a polynomial with just one term, it's called a monomial. 2 terms is a binomial. 3 terms is a trinomial, and then anything bigger, 4 or bigger, poly just means many, so we'll call it a polynomial. Okay, so if I want to multiply, we're starting out by just multiplying by a monomial, right? Something that's just one part. So I'm going to take negative 6y, this monomial, and I'm going to distribute it. We've already done this, right? So we're just practicing this and kind of making the story complete. So if I distribute my negative 6y, I'm going to have negative 6y squared. Negative times a negative will be a positive 18y. Same thing here. 7n times 3n will be 21n squared. And then 7n times negative 2m squared will be minus 14m squared n. Okay, so that's just the distributive property. So we use that if we're multiplying by a monomial. If we are multiplying by a binomial, we need to use FOIL. And I'm sure you've used this in the past, but FOIL stands for the first, the outside, the inside, and the last. We're basically using the distributive property twice. Oops. So the first step is for distributing the 2y. So I do 2y times both of those. And then the second step is distributing the 1. So then I take 1 times both of those. This is just a nice way to remember, right, those parts. So the first times this first is going to give me 10y squared. Outside would be 2y times 1. Inside would be 1 times 5y. And then the last times the last would be 1 times 1. Not always, but many times these two middle terms will be alike so that we can combine them into 1. Okay. There are some special products that use this same process but give us a special result. So I want to just show you a couple of those. There are some patterns in what we're doing, and so some people really like to use the patterns. I personally don't see it that way. I like to use FOIL and kind of use that one method to carry me all the way through. So you can do it both ways. All of these patterns are listed in the book if that's something that you're interested in. Okay, so let's try this one. If I have x plus 4 times x minus 4, sometimes this is called the product of a sum and a difference, because one is a plus and one is a minus. But I can FOIL it out the exact same way I did the last example, right? So x times x will give me x squared. On the outside, I'll have negative 4x. On the inside, I'll have positive 4x. And then 4 times negative 4 gives me minus 16. The special thing that happens here is that the two middle terms are equal but opposite in sign. So because they're opposite in sign, they add to be 0 and cancel each other out. And so we're left with x squared minus 16. This is important to kind of recognize because in the next video we're going to be talking about factoring, and we're going to see a difference of two perfect squares, and we're going to factor it back into a sum and a difference. So this is us kind of looking at this pattern in the forward direction, and in the next video we'll look at it in the reverse. Okay, it's good to look at examples like these two together because they are different and they're easily confused. If I have y plus 5 squared, the square here means I'm going to multiply two equal copies. So two copies of y plus 5. I'm going to write it here. Notice this is not the same as this, right? This is two copies of the same thing, so because this is a plus, they're both plus. Where up here, the signs are different. They're two different things, two different patterns we're going to see. Okay, but we can still FOIL this out just the same. So if I FOIL this out, I'll have y squared. On the outside, I'll have plus 5y. On the inside, I'll have plus 5y, and then 5 times 5 gives me 25. This time, the middle terms do not cancel, right? These are the same, but they have the same sign. So we're going to add them together, and we're going to get sort of a doubled up middle term. And so the pattern here is that double middle term. Whoops, I'm saying double, so I was trying to write a 2, but it's double of 5, which would be 10. There we go. Okay, another good thing to note. So two things that are noteworthy. These are not the same. Second, I can't just distribute the square, right? Notice I did not get y squared plus 25. If I had done that, I would be missing this middle term. Okay, so this is not the way to go about it. All right, so those are two special products. All of these last several examples were multiplying binomials, two binomials. What if we have something bigger than that? We're still using the same basic process. That's still the distributive property, but now that we have more pieces, we can't exactly call it FOIL, but we're still going to be multiplying x times everything in the second parentheses, and then multiplying 1 times everything in the second parentheses. If you want to be super organized, you could actually write it out that way and not distribute the x yet, but sort of identify this is what I'm going to be distributing. I like to do it that way because that way I know I didn't miss any of the parts, right? 2 parts by 3 parts means I'm going to get 6 pieces before I combine like terms. And it is good to make sure you don't miss any of those. This is my way of making sure I don't miss them. Okay, so I'll distribute my x, and I'll get x cubed plus 2x squared minus 3x. And then I'll distribute my 1. just like with all the others we've done tonight, we want to write it in descending order, and we want to combine the like terms. So we're going to start with the x cubed. Then we have 2x squared and 1x squared. So together that's going to be 3x squared. We also have negative 3x and positive 2x. Together that's going to be a negative 1 or just a negative x. And then we also have a minus 3. All right, so what we did today was we looked at a definition for a polynomial. We talked about some of the vocabulary that go along with polynomials, and then we took some time to do adding, subtracting, multiplying. That's all. Adding, subtracting, and multiplying. All right, so this will definitely take some practice, especially if you haven't seen it in a while. So good luck with that, and we'll see you in the next video.